so you could see me. Hi, everybody. It's Phil with Genetec. Thanks everybody for joining. Boy, oh boy, was I shocked at the demand for this session. So I'm incredibly honored that you'd all take a few minutes out of your time on a Friday to sit through this. I am sure the reason you're here is because you're either forward thinking and you're looking at these different requests as they're coming in, or you've seen a lot of information out there and you just want to get more, and maybe you even want to know, like, hey, what's Genetec's stance on this? And I'm not gonna get into like where Genetec stands. What really the ultimate outcome for this is to just spread some good information. There's a lot of information out there, let's say, and not all of it is great. So I've actually prepared a bit of an opening statement, and then I'm going to open it up.
Is now exiting.
Let's start there. Bear with me. I'm still admitting people to the room here. All right. So
I got the admittance. It's okay.
Okay. Oh, thank you, sir. I didn't even know you were there. That's Steve Pendino. He's the sales engineer in the great state of New Jersey. I'm Phil Coppola. I'm the regional sales manager in the state of New Jersey as well. So like I said, I want to start off with just a quick opening statement. So I've been in the security technology industry for 20 years now, and I've seen a lot of technology come and go. In my starting days, we were selling time-lapse recorders with black and white analog cameras, right? Then came DVRs, then came IP cameras. And there have been a few fads that came and went, and the demand for those products rose and faded in the manner in which you would expect. Today, however, we find ourselves in a bit of a new world, a strange new world. And there's a new fad, one that has the potential to make a difference, but also one that is the source of a lot of questions. Of course, you know what I'm referring to: thermal cameras for the use of so-called fever detection. And we're going to get into that term quite a bit. In my view, in my personal view, as an industry and as professionals in this industry, we have a duty and we have an obligation to represent all of the technologies that are in our arsenal in a responsible manner. For far too long, the general consumer has been fed misinformation by television shows and by the movies at what surveillance cameras can do and what other security technologies are capable of doing. We all know the CSI effect, right? Oh, zoom in and enhance. And none of that is true in any way, shape, or form. And my fear is, with the current situation and the prevalence of opportunistic sales organizations, that both our systems integrators and our end users may make decisions based on limited information, which may lead to poor and unforeseen outcomes in the future. The goal of today's call is to simply engage in a conversation. This is not a sales pitch. You're not going to see a PowerPoint presentation. You're not going to see Genetec presenting some sort of blue pill that's going to somehow mysteriously solve the COVID-19 crisis with thermal imaging cameras. This is not the intent today. At the end, my goal is that you simply walk away with a better idea of thermal imaging technology, its proper uses, its potential drawbacks, and of its use in general moving forward. Keep in mind, these solutions were never designed for this purpose, right? So I've asked Vin from Mobotics to join me on the call, and you'll be listening basically, hi Vin, you'll be listening to our conversation. While there are other brands that offer a similar solution, I wanted this to be as close to a discussion as possible, not a roundtable. I didn't want to crowd this with a bunch of different manufacturers because, again, I didn't want it to come across as a sales pitch in any way, shape, or form. Mobotics is a recognized market leader, and they're taking a similar approach in terms of their communications as that of my organization, Genetec. So again, no sales agenda here. This is all about the dissemination of good, valuable information. If you have questions, I ask that you type them into the chat session below, and time permitting, we'll answer them as best we can. Please be sure you're muted. And with that, I introduce Mr. Vin Imbesi from Mobotics. Say hi, Vin.
Hi, everybody.
Happy to be here with you, Phil.
Thank you, Vin. And also joining on the call from Genetec is Steve Pendino. Steve is the sales engineer for Genetec and the person that usually keeps me in line. So if I get crazy and I start saying crazy stuff, Steve will come in and hit me over the head.
I'm the no to his yes.
Thank you. That's a great way to put it, actually.
Oh, there he is.
So I wanted to let's start, Vin, at the very basic layer. What is a thermal imaging camera and how does it work?
Yeah, so I should turn this off so I don't get that again. So thermal imaging is different than any other cameras that you have out there. Those of you who know thermal imaging, we're just gonna pretend like we're starting from the ground up, right? So what a thermal imaging is, it essentially, unlike visible cameras, which are looking at a certain spectrum of light, thermal cameras, infrared cameras, are looking at essentially radiation. It's taking in heat signatures, radiation, digitizing that, and creating an image off of that. Now, it's not new technology. It's been around for a long time. People typically know that. People don't typically know that there's actually two types of thermals out there. There's one for security, right? Everyone pretty much is familiar with this. If the police are looking for somebody in the woods, that's the type of thermal they're using for. That's the one they're using for invisible fence lines, people detection, prison yards, right? Anywhere you want to detect a person or a visible light camera is going to struggle. Thermal cameras do really well because it detects the heat versus the background, which is typically very cold compared to the heat signature. So it's phenomenal as far as detecting human beings, dogs, sometimes vehicles in dark places or vast distances. And we've done that. But more interesting and something we've been talking about for quite a while, we've been doing for years, are thermal radiometric cameras. Same kind of principle, right? Same sort of sensor looking at the same spectrum of light radiation, digitizing that, creating an image. But what it's doing is actually a little more sensitive. They're a little more expensive. Thermal radiometric cameras are not for security purposes. The goal of a thermal radiometric camera is to monitor objects. Right? So I have been deploying these cameras both in this role and previously, and the objective, typically where we're deploying these successfully, preventative maintenance on machinery. We're using it to monitor heat for any kind of electrical circuits. We're very, very popular with this product in oil and gas, as well as my competitors. I'm not focusing just on robotics here. I'm talking about these thermal radiometric cameras, which is not a trademark to robotics. It's a sort of camera, right?
Sure.
These cameras are typically deployed in those areas. They're also very frequently deployed at like trash facilities, recycling facilities, to monitor combustible heaps of trash for fire. So it would be an early warning fire system.
Right.
It'll tell you the second that pile starts heating up, long before any smoke or anything starts coming up. So these applications have been here, and we've been deploying these cameras, this specific camera that we're offering for this, for years to tackle this globally.
Right.
And so now this comes up. We had dabbled in human detection before, body temperatures and whatnot. I've have a couple demo clips from last year when I first started, and we just kind of like shrugged it off because there was no market for it. No one really interested in it. There was really no need for it. Certainly people were not going to spend thousands of dollars to deploy one. So it was something that we kind of dabbled in and kind of forgot about. But it's all the same concept. Thermal radiometric cameras are not for detection. They are for monitoring temperatures and objects.
So which one would be if you were going to use it to detect the temperatures of people, which one would you use?
The thermal radiometric one.
Thermal radiometric. I'm actually going to get a pen and write that down because I did not know that.
Oh.
Thermal radiometric.
Correct.
Okay. So that's important, folks. Take notes. So thermal cameras and the term fever detection. You and I were having an interesting chat about this, and you told me something that I did not know. Now, I'm going to preface this question with, I did see, and Lynn, I see that article that you posted in the comments section, that apparently the FDA is going to start looking the other way in terms of people marketing this type of technology as fever detection. But can you explain to everybody on the call why the FDA takes such a hard stance on devices for fever detection specifically?
Well, they haven't. They just decided that they wouldn't, right?
Well, before today, right. Why were they taking such a hard line?
Because the FDA always likes to control things, right? So the term fever is a medical term. So until this, you were basically taking temperatures with thermometers, right? And like anything else in life, non-contact thermometers, there's really crappy ones that are inaccurate, and there's really high-grade ones, the ones you find in hospitals. Those spectrums still were, in order to be able to deploy and to register a temperature as a fever, you had to have a certain amount of accuracy. So the FDA started issuing, I guess, their stamp on degrees that if they hit certain and performance thresholds to be considered FDA approved.
So, and this is the really interesting thing that that I did not know. Can you tell me what the difference is between a thermometer, a non-contact thermometer that is used to detect temperatures, and a thermal radiometric device?
Yeah. So this is something a lot of what I'm going to say, some of you may have already heard me say it. It's very much our talk track because it's simply the truth. If a facility is looking for accuracy, that's the only thing that they're concerned about. We want to know if someone has an elevated temperature coming into our building. Then using a non-contact thermometer, FDA approved non-contact thermometer, is the most accurate way that we have. Now, even those are inconsistent, so we'll specify that. Using a high caliber, high quality non-contact thermometer realistically is the best way to externally take a temperature of people entering your building, right? It's non-invasive, all right?
Right.
Obviously, hospitals have other methods of doing, but we're talking about people walking into a building, right? If that though, however, presents its own challenges, especially in today's world that we're finding. And I promise you I will circle back on the whole fever, non-fever thing, right? But
yes, no problem. Yep, take your time.
So many times, using a non-contact thermometer is impractical based on the volume of people you have coming into your building, right? Think about airports, train stations, malls, hospitals, right? That serves a problem based on the bottleneck it would create on people coming in. Sometimes facilities don't have the manpower to put employees up in protective gear to scan all those people as well. They also don't have the budget to pay those people because they're not going to do it for free. You got to pay all those people to scan people all day long. So when those are not an option, when using a non-contact thermometer is not an option for those reasons, using a thermal radiometric camera to screen people for elevated temperatures simply is the best technology that we have. The best way that we can do it on the planet today is with this technology. With that said, it is not bulletproof. And this is some of the things I know Phil is very concerned about. And I know that thermal manufacturers in the media have the reputation of kind of shying away from this, but we never have. I never have. I've been very frank with what these cameras do, what they don't do, and the accuracy that they report. So, when this first started coming out, coronavirus hits. Well, I've been out there, I've been selling these cameras for years, most recently at Mobotics, selling them for fire detection and all those other things. Coronavirus hits, I start getting all these phone calls. And I thought, well, this will blow over. It's obviously not a coronavirus detector, right? I mean, let's very much get that out in the open. You can have coronavirus and not have a fever. So these are not coronavirus detectors. So then I thought, okay, surely people will realize that, and then these phone calls will stop. And I kept getting phone calls and I kept getting emails. And I said, okay, well, surely once they realize this is not 100% precise, then people will stop calling, this will blow over, it's a fad. And I kept getting phone calls and I kept getting emails. And here it is 3 weeks later, I finally have a good understanding of what this is and what this isn't. And that's sort of what I'd like to educate people on.
Yep.
So what this is, it is a device where if properly calibrated, properly deployed, and the right protocols are put in place, we personally are seeing it accurate within half a degree under the right conditions. Half a degree, right? So what that means, assuming the people are not covering their face and running past the camera, or they're not wearing 2 scarves and sunglasses and a hat, right? You got to make sure that they're following the right protocols. If they do that, we're seeing under half a degree of accuracy. Now, it will miss people. So if you have 99.1 fever, it's probably going to miss that, or it very well may miss that, right?
Well, see, and I want to really drill down on this particular topic.
Please do. Yeah. This is important to me too.
Because there are a ton of variables that need to be taken into account here. This is not like set it and forget it, just like all the other video surveillance cameras that we're going to stick in a corner, hit record, and it's going to grab everything in a scene. And I compare it to video analytics, where, I'm going to take an object left behind analytic or an object removed analytic, and I'm going to run it in a very controlled environment, and it will tell me when an object is removed or an object is left behind. Now I'm going to take that same video analytic, I'm going to take that camera, stick it in a corner, give it its widest possible field of view, and put 100 objects in the scene. And now I want it to be just as accurate as that controlled scenario. And of course, it doesn't work that way. Unfortunately, again, going back to my opening statement, it's sold as if it will work that way, but then the end users and the systems integrators end up finding out the harsh reality. So I'd like to understand, what are the little idiosyncrasies? What are the variables? And before we get there, going back to the fever detection versus non-fever detection thing, one of the things that you told me on the call is the difference between the thermal radiometric device and the thermometer is proximity, right? There's the lack of variables between 1 inch away from your forehead and 50 feet away on a wall. So let's talk about those variables and what the systems integrators and the end users that are on the call that are thinking about either marketing or deploying this technology, what they should be considering when they deploy.
You covered an awful lot of ground there.
Yeah, sorry, I had to be very verbose.
Let's start at the infrared part, right? So we mentioned the non-contact thermometer, most accurate way to do it, right? If that doesn't work, using an infrared camera is the best second way to do it on the planet, despite not being bulletproof. And then what I found was that's what it is, right? And again, we are not these vultures that are out there hawking this product that are trying to take advantage of people. The bottom line is this product will identify some threats in a building. We will flag people with 100-degree fever, 101, 102, 103, 104. It's not eliminating coronavirus. It's not eliminating threats. It's not guaranteeing that no one's getting into your building that's sick. It's reducing some of those threats and giving you a way to screen some of those people out that you otherwise just can't do.
Right.
So it's not this evil thing. So going back to non-contact thermometer, right, is actually an infrared sensor. So the reason that's more accurate, as Phil alluded to, it's an inch away from the skin. It knows it's looking at skin, so it's taking away all environmental information. It's taking away all environmental factors and all distance factors. It's an inch away, and it knows what it's looking at, because there's actually something called emissivity. Emissivity is the term, if you Google it, it's a term that deals with the amount of heat or radiation a surface absorbs or reflects based off the type of material it's made and the texture, whether it's polished, whether it's grooved, porous, that sort of thing. So that little tiny device, it's only looking at one thing. It knows it's looking at skin. So it probably has a little tweak in there. There's no distance, there's no variable limitations. Boom, it just works. Where we're seeing success for deployments, I guess this is where you want to go now, Phil, right? Deployments?
Well, not necessarily. What I want to get an understanding of is those variables, or are those variables? So I'm an inch away from your forehead. I use a non-contact thermometer, and I have a relatively small window where I'm going to be inaccurate. I now take that same technology, pull it 50 feet back, put it on a wall, give it a wide angle field of view, and tell it to look at people. How many people? What are the environment? What is the optimal, based on what Mobotics sees? Yeah. What is the optimal conditions for deploying? Because I have a sneaking suspicion that if you set these cameras up, and here comes the question from James. That's a great question, because that's exactly where I was going with this. Can you set them up outside? What are the variables that need to be considered there? Because in my view, I don't think I would put this outside, because you've got too many other temperature variables, whether they're moving vehicles or the sun or clouds. And then even putting it inside of a facility, there's got to be variables there. So can you talk to that?
Yeah, we'll talk indoor, outdoor first, I guess, and then we'll talk about distance and all that stuff second. So we'll kind of start macro and we'll go smaller. Indoor versus outdoor. It's to be proven yet, right? So I as a manufacturer, I see information coming into me, but I haven't seen it myself. I saw a clip of in I think it's Chile, where we have a camera 10 feet away and it's outdoors and people are walking up and they're going in the door. So does it work outside? I would say yes, but I probably wouldn't try it, right? You probably could, but the thing is, if a manufacturer is guaranteeing you anything, if I as a manufacturer issue a blanket statement whether something works, you probably shouldn't trust me. I don't know where that is. I don't know if it's covered.
It's a good answer, by the way.
Right? You got to think about, even if the weather changes, skin temperature is going to change, and then you got people bundled up because they're outside. To me, I don't like my chances. I like my chances outside if I can at least start eliminating some things like rain. Is it sheltered outside? Right? Now we can start having a discussion and go, okay, we would ultimately arrive at me telling you, okay, Is it sheltered? Yes. It's still outside, fine. But now we're going to make sure you put the camera as close as possible. We're going to use a Blackbody Radiator, which we'll talk about in a minute. That would be 100% required. Make sure you do that. And then we would always end up at the same result, which is let's go with one, put it in that specific facility, let the end user decide if that is enough of a protection for what is accurate enough for what they want. Gotcha. I know it's not the answer that people want. People want the blanket statements, but that's what's kind of getting people in trouble.
No, and that's the answer that I want everybody on this call to hear, because that's the way that it needs, that's the sort of baby step approach you need to take to this. You've got to vet these solutions, and you can't trust the marketing material that's making its way all around social media and everybody's talking about it. You know, forget about the cybersecurity implications and whether or not it even works with Genetec or your existing video management or access control platform. Forget about that. Will it actually do the thing that you want it to do? So you've addressed putting it outside. Now, what about putting it inside? What are the variables that need to be considered there?
Yeah, so obviously if it's, assuming you're indoors without, double swinging doors to the left or right of you, right? If you're in a controlled environment, we have a lot better chance of guaranteeing accuracy. Even then, we as Mobotics and FLIR does the same thing, and other ethical manufacturers, you're not seeing us issue a blanket statement promising X amount of degrees, because there are many things that the deployment of the camera is probably more important than what I'm doing on my end. I can take all the steps in the world and I give you the best sensor in the world. If you're putting it up 30 feet in the air and trying to cover a shopping mall, it's not going to do anything for you.
Right.
So people that are issuing blanket statements on accuracy without considering the factors inside, which we're going to talk about in a second, are not playing by the rules, or they're not really being ethical about it.
Yeah, it's not super ethical. And to that point, I get the same questions like, can we do X, Y, and Z? Can you trigger a threat level, or can you do something with the access control system if heat is detected? Yeah, we can, but what level of accuracy can your device guarantee?
Yeah.
Because I'll do whatever you want with the data, but how good is that data? This is the question. So go ahead, talk about indoor.
So when I talk about, so I was saying that we don't issue blanket statements, but we do talk about accuracy, but this is how we present it. If the camera is properly deployed, if it's properly calibrated, and the right protocols are in place, right? Now I can talk about accuracy. If those three things are hit, we are seeing about half a degree, under half a degree of variance, a little under sometimes, under half a degree of accuracy between actual temperature and registered temperature. Okay. But it's always important to have those three things. It's almost like a disclaimer, because those things are true. Distance is a big factor. So ideally, you want that camera within 10 feet of the target.
Wow. Okay.
I've seen it longer. I've seen clips of it 15, but I'm not comfortable saying 15. I'd rather say 10. This way, sure. If I say 10, you'll go 12. If I say 15, you'll go for 20. And now I'm getting uncomfortable. I always want to present this in a way to put people in the best position to be successful with it, because if not, then all of us get in trouble, right? So within 10 feet of the target, you want the camera straight on, perpendicular. You want to see their face. If the camera's in the ceiling, then you run the risk of getting their hair, their hats, their forehead, the top of their heads, that sort of thing, no good. If it's off to the side, you're going to get their ear, the side of their faces, their chin, no good. What we really want is, again, the camera within 10 feet. We want the camera at eye level, or down off the ceiling, ideally, and then straight on, and have people walk. We don't need to stop, right? So now we're going to talk about the word accuracy. And accuracy, or is it, the way to look at this is it accurate enough? And that question is different based on whatever the end user is looking for. So what I will do is we'll talk about things that make it more accurate, but I'm not saying that it's required, such as stopping. Are they required to stop? It depends. If them walking by slowly enough, if it's calibrated correctly and it's positioned correctly, and you're getting accurate readings without them stopping, they don't need to stop. It doesn't matter if stopping could make it more accurate, right? It usually does make it more accurate. But is that 0.1 degree enough of an accuracy to change your protocols? It's probably not.
That's a policy question.
Yeah, a lot of this relies on, I can't see the questions, unfortunately. I got to figure out where that pane is. But a lot of this relies on those factors more than the accuracy, the blanket itself. You know what I mean?
So within 10 feet of the target, limited viewing angle, like limited angle, straight on. Yes. This will yield you the most accurate result. And then moving versus not moving, depending upon the scenario. And so this is the other question. Controlled environment. In other words, I'm not putting this camera in a lobby with a giant plate glass window behind people as they come in, right? I'm doing this in an area that is 100% controlled for temperature.
So in an ideal world, yes, but the reality is that's not going to happen. But we have some ways to mitigate that. So you've got the camera up. Typically, we're seeing them on a cart, but it doesn't have to be on a cart, right? But you have these stations, and these are going to be so massively deployed, you just can't assume that the environment is going to be controlled, right? Again, we want it indoors, but there are ways to start mitigating around that. So we have two ways, or let's start with one way that's not robotics related. There's something called Blackbody radiators.
Yeah, I was going to ask you about that. What the hell is that thing?
Yeah, so camera manufacturers don't make them. They're all third party. You might see them bundled in with the camera. They're still third party, but they bundle it out of convenience, which I'm jealous of, because I wish we did that. It's easier to sell. But what a Blackbody radiator is, it's a box like that big, and it's got a little square in the middle, and you put that in the background. So if you're the camera and I'm in front of you, you would see this thing over here or down here, anywhere.
Right.
And what that is you set it. You say Blackbody radiator. I want you to radiate heat at precisely 107.1 degrees. So the camera sees that in the background, and it's constantly telling the camera this spot is 107.1 degrees. Mm. And the camera's using that to compensate for whatever changes in temperature there might occur. It's keeping the camera calibrated. In an ideal world, you'd have that background of every camera.
So I want to repeat that. In an ideal world, you'd have that in the background of every thermal camera that you had for higher accuracy, correct? So I'm on the internet, as it were, and I did a search for Blackbody generator, and what I am seeing is in the range of $500 and up per Blackbody radiator. Yes. So, right, and it looks like, I mean, they even go up even higher than that. I'm looking at one for $5,000 right now, $12,000. So
it gets worse, Phil. I, as the manufacturer, I know my camera is going to last 10 years. You buy a $500 Blackbody, I have no idea how long that thing's going to last. Right. Like I'd like to control, if my system is relying on that, I would like to standardize on one, but we just haven't gotten there yet because we haven't done this long enough. We as in the industry. Yeah. But just so you know, there is some debate on whether one is required. And let's talk about that word required again. Okay. There is no question that using a Blackbody radiator will increase accuracy. If you can't get one, or you don't have the budget for it, or it's not in an airport where they do have the budget, if it's in a small store and they just really want to do the solution. The debate right now, and we'll know with time, is whether you need it, whether it's absolutely required. There's no doubt it makes it more accurate, but is it accurate enough without one in a controlled environment? If it's outdoors, you absolutely need one. If you've got double bay doors that are open all day, or if you've got environment that's changing, you definitely need one. I wouldn't even really attempt it without it. But in a controlled environment, we are seeing it work without it. Right. We as robotics are seeing it work without it. From my perspective, I haven't seen enough to recommend not having one.
Sure.
But just keep your eyes out that we might get there eventually. Now, some people are also saying, okay, I have 5 cameras for a building. I'm going to buy one, and I'm going to calibrate it with that thing in the background, and I'm going to move on to the other 4 cameras. Yep. So I think people are doing that as well. The jury, I don't know. I don't know what the end result is, but you will see varying degrees of opinions based on who you talk to on this. But they all kind of agree on the same thing, that having that will increase accuracy.
So speaking of opinions, we got a comment here in the comment section. It's important to understand the differences of Blackbody units. Typically, low-cost units only absorb and emit the same exact temperature, and that's usually absorbing ambient temperature. Blackbody radiators emit exact dialed-in heat, i.e. radiator, right? And Hunter also points out you will not find one for $500 as they won't work. So I guess that's something that we should also keep in mind. I mean, as a security professional, before this week, I had never even heard of a Blackbody radiator or generator or whatever the hell these things are called. Simon Barnes wants to know, how often is the Blackbody device calibrated itself? That's a great question. Do you have any idea?
I don't, because we don't make them, but my understanding is it's a digital screen. It's like a clock. It's supposed to, I don't know, I guess to check internally its job is to emit whatever you tell it to emit. So I imagine the less expensive ones won't monitor itself, and the the more expensive ones will.
Yep. So
Phil,
yeah, go ahead.
You brought up a couple of things on previous calls too, which is, what happens if somebody pops a whole bunch of Advil before they come to work? Well, now I don't necessarily have a fever anymore.
Yeah.
No way to detect that.
Yep.
Same thing. What if I just went for a run in the middle of July? I can't imagine doing that myself, but other people do it.
Yep.
Same thing with
people
a workout.
Crazy.
Yeah.
Sure.
So let's circle back to something we didn't actually wrap up on. So the non-contact thermometers is an FDA approved device. Up until this morning, FDA approval mattered a hell of a lot. So I'm excited because it'll help open up the market, but I'm a little frustrated because we've already applied for FDA approval. We're anticipating it because we're a major provider. So now this is just going to kind of even the playing field a little more against inferior products out there. But it is what it is. So let's just pretend like it matters for the moment.
Sure.
So
sure.
A medical device is the only thing that can tell you if you have a fever. Unless that thermal camera is FDA approved, it should not be using the term fever. Fever is a medical term. So what we're saying, right? So if you're going to kick somebody out of your building, you better be sure they have a fever, especially if they're like a client, right? So let's go back to protocols. We want this camera within 10 feet. We want it at eye level, and we want people walking towards it. We also want it monitored, or we want someone stationed there as well, supervised, right? For a couple of reasons. One, beep, if it detects me, what's going to happen to me? If no one's there, I'm going to keep walking. Now you're pursuing somebody with a possible elevated temperature in the building. That's no good.
Right.
So having somebody there will make sure protocols are followed. It'll also allow you to do this. Beep, camera detects me. You then pull me aside and take my temperature with an FDA-approved non-contact thermometer. If that gives you an indication of a fever, which again, that's what's going to tell you have a fever, now you've got a right to kick that person out of your building, and you're more protected in that regard. Right. These products, they're screening products. They're not, if you went for a run in July, it might pick you up, and then you pull that person aside, you take their temperature, and if they say, I was just running, give me a couple seconds, you take their temperature again before you kick them out, if you believe them, right?
Right.
One of my coworkers equates this to like a metal detector at an airport. If I have a metal plate in my arm and I walk through and it beeps off, it's not saying that I have a gun and I'm going to hurt somebody. It's saying, hey, you should pat this guy down. We're kind of doing the same thing. Hey, this looks like it might be a problem. Check this out.
And so to that point, and that's where Genetec typically gets involved, because now whether it's Mobotics or another camera manufacturer, we're going to receive the alarm event into our platform. Then what do we do with that information? Because I think a lot of the people on this call want to know what can I do? Like what's the best practice? What's the best policy? We don't know. The fallback line is best practice is whatever the best practice is for your organization. But I think to Vin's point, by using these devices as a screening device and implementing a screening protocol, if you have guards at your front desk, if somebody gets scanned and the alert goes off, we can send that information to them, and then they can respond accordingly. So here's another question. Can these cameras be integrated with access control HR systems to flag employees as they enter and lock out access for higher temperature readings? Theoretically, yes. Like I know for our platform, it doesn't necessarily even just have to be based on a heat sensing, but you can say, if this condition is met, deny access on this door, not necessarily for an individual, because you wouldn't know. There's no way to tell which individual in your organization had the high temperature, but you can certainly restrict anybody's ability to get through a door if somebody was flagged with a higher temperature. But again, this is all going to be based on policy and procedure. And that's one of the things that I wanted to use this time to talk about, are like these unintended consequences, because that's a fantastic question. And I think that's where a lot of our minds go, is like, we'll use the access control system to deny access to anybody that has a temperature that's above a certain degree. That does not help us with the person, like in Steve's example, that took Advil that morning, came to work with the flu or whatever, had a normal temperature when they went through the door, and then continued to infect people as they got through. So it doesn't prevent against that. So what then do you do? So we've restricted access to that door. We've identified that this is the person that we don't want in the facility because they have a higher temperature. Where are you putting them? What's the policy? What's the protocol? I don't have your answer. I'm not legal counsel. I certainly recommend you run this by your own legal counsels. But my question as a security professional would be, okay, where am I going to put this individual? Am I going to have like an anteroom? Or I'm going to put them aside and I'm going to put them in there. Now, in Steve's example, I just ran, 5 miles in the middle of July and my temperature is 102, but I'm okay. And then you flag somebody else. Do you put them in the same room? What if that person gets that person sick? These are all like these sort of unasked questions that nobody is really at. Like the rush is, can we do this? Yeah, we can. Should we do it? How do we do it? How do we develop a policy to do it? These are the questions that I find are not necessarily being asked. So I want those thoughts to be permeating the minds, especially of the systems integrators and of the end users that are on this call that are listening to this conversation. Because Steve and I were on a call yesterday with the police department, and we started to talk through these scenarios, and you could tell on the call, like, wow, you know what? We want to do this, but we hadn't considered this. And one of the other things that they hadn't considered was, let's say you have a police officer who just came in from a run. He's coming in for his shift. You pull him to the side and say, you can't come in, you're running a temperature. Well, is he now on the clock or is he not on the clock? Now you're going to start running into labor union potential issues. And again, I'm not a labor union lawyer. Please run this by your own legal counsel. But these are like these unintended consequences of implementing these types of systems. So before you even deploy, before you even think about vetting the cameras against your access control, your video management system, my recommendation would probably be, again, as a security professional, develop the policy, run it by human resources, run it by your legal counsel, see if what you're trying to do is even proper before deploying technology. So let's run through the rest of my questions. I think that's pretty much, you've pretty much answered them all, Vin. As well as a couple of extra ones. So one of the things that I did want to ask about is just with regard to weather. So we talked about putting the cameras outside. We can do that. Should be a controlled environment. You should have an overhang. People should not be wearing all sorts of get-ups. But now coming into the facility, let's say it's a hot day in July, 100-something degrees outside. I come into the facility. Is there any data that says like how long it takes the body to cool off? Because my thought is, if I come in and the detection system is in my lobby and I'm still 102 because I just came in from outside and I'm boiling hot, is there a recommended like cool off period, or do I need to put the camera further into my facility or make that environment even more controlled?
You can do, I think it's going to be a case-by-case basis. Everyone cools off at different temperatures, but what you could do is you could move the camera, you could cool off the space, you could actually change the temperature thresholds too. So if everybody is coming in hotter, then you just make an adjustment in the camera to make it have 1/3 of a degree or 1/4 or 5th of a degree off. You can kind of change the threshold, not the threshold. Well, you can change the threshold, just do that, it'll be easier. Hey, maybe it's normally, let us know if someone's at 100 degrees. But if it's the summer, let us know if it's 105, 100.5, right? Half a degree or 1/3 of a degree. You can do that too. You just modify the alert.
But then the drawback there is, if somebody is actually 100.5, you're now letting them into your facility, even though they may have a fever. So that again, these are the things that have to be considered and bandied about, because the other thing you certainly don't want, just with like Steve and I were chatting about this yesterday, you have a lot of video analytics companies that have weapons detection, and there are very specific applications where weapons detection, early weapons detection, is fantastic, but there are other applications where it's not. And if depending on how good the analytic is, if you have a false alarm on a weapon being detected, that's a really bad false alarm to have, right? Nobody wants that scenario. And I think we don't want these fever detection methodologies to have all sorts of false alarms either. So we're going to constantly try to dial it in and have it be just right. And are we willing to accept that a certain number of people are going to get by it and still be carriers of whatever they're carrying. So again, just because these systems are deployed, they still need to be deployed in a responsible, reasonable way in controlled environments that are going to prevent the majority of sick people from coming into your facility. But like Vin said earlier, anybody that's claiming within, X number of degrees, we're going to know 100% of the time, I think is sort of ambulance chasing and is selling a little bit of snake oil. Right. So Vin, I wanted to last few minutes answer some of the questions that are here. And this is one that I've gotten a couple of times. Should these systems be FDA certified for 510K? Or 510, I'm guessing K being Kelvin. Does it matter if they're used for initial screening, then screened again by a certified thermometer? So I think we answered that question. Do you know what the 510K thing is?
That's the FDA certification we're pursuing.
Ah, okay. There we go. So we shall find out shortly if you are FDA approved, although I guess everybody's FDA approved now because this is the world that we live in.
We've been out there. It frustrates me. We're a major thermal manufacturer. Long before all this came up, I talked to both of you and Steve. I'm like, you got to see this thermal camera. It is doing amazing things.
Yes.
We're out there. I'm selling this thing for all kinds of environments and deployments globally, very successfully, very accurately. And now this hits. And now all these people that I've never heard of come out of the woodwork with their flashy green and red boxes, claiming to be experts. And it just infuriates me because
it's aggravating.
Just because it shows a picture with nice things doesn't mean that it is accurate. And I know mine is accurate. So I feel pretty confident about having discussions like this. And I feel pretty good, especially if I'm putting you in a position to understand what these cameras can do, what they can't do. If people are all on the same page, it all comes down to the same thing. Once again, what this does not solve everything, but it is undoubtedly a layer of security you don't currently have that will remove some threats that otherwise going to get into your building.
Awesome. Well said. So a couple more questions, and we've got a couple of these, so I'll bundle them all together. Looking for a thermal camera solution to protect police officers going on calls, or in other words, like a handheld. You guys don't make that, right?
We don't. FLIR has one. FLIR makes good products.
Yep.
They're the only handheld ones that I've seen, but I know there's probably some others out there.
Yeah, and an important note about FLIR, prior to today, they only had 2 FDA-approved thermal imaging devices, but neither of them had video outputs. So you couldn't really even use them for these types of applications. But I'm guessing the right answer here would be deploy the police officer with a thermometer, a non-contact, FDA-approved non-contact thermometer. If you wanted a camera, obviously we could talk about cameras in cruisers and body wearables and all that stuff. And I'm sure in 6 months from now, some manufacturer will have a body wearable camera with a thermometer on it or some sort of infrared that'll take body temperature. Just you watch. I should patent it. I have patent pending. Nobody take my idea.
You are going to see all kinds of stuff. I mean, this is not a fad. It's going away. I saw online Disney announced, hey, when the parks open up, we'll probably start screening for temperatures right now.
Yep.
You and I know what that means. He didn't say we're going to look at infrared cameras, but what other way are you going to do it?
Yeah, unless you're going to take everybody off the line and scan them all individually or take a blood test or something.
Is now exiting.
So next question, how much separation between targets? Does that matter? So if I have 15 people walking side by side, or I've got a bunch of people like a crowd clustered together, how is that different?
So I don't need, you could walk hand in hand. You could have two turnstiles next to each other. That's not really so much the issue because I'm going to draw that sensor bar. I'm going to draw my area of interest basically across vertically, horizontally in that manner. But the problem is if you try to do 15, how far back are you moving that camera to get 15 people standing next to each other?
So it all goes back to the controlled environment question. Yep. So we're right up against 3 o'clock. We've got a few minutes left. Any other questions? Here's a good one. What would a throughput be? How many people per second in a straight line?
In a straight line, you're just gonna bang out. You would draw a box here and a box here to get someone in the immediate ground and the foreground, and then just keep let them go through.
And to that point,
slowly anyway to be accurate, right? So it's not that like, hey, how many people can we run by the camera? They're only going to go a certain speed, so they're not going to have to stop though. So just think of an airport. Think of people walking in a common way to the airports. We'll get them all. I mean, when we're doing that at San Juan Airport, we're scanning every single person in the facility to exiting and leaving, and we're getting them all, whether they're side by side or two adults and a child, or a person here and a person there. We're getting them all.
Where I was going with that is if you have a line of people and people are coming through, this is not facial recognition either, right? So if I have a trigger and I have a steady line of people coming into my facility, you need a good policy in place as to how fast you're going to respond to that incident, right? So now how many people do I have to pull off the line if one person is detected in a rapid moving line? So this is, these are the things that we should be thinking about as well. In terms of what specific Genetec platform are we talking about? So Genetec has Security Center, Omnicast for video, access control is Synergis, AutoView is license plate recognition. We can absorb whatever alarm data gets thrown at us from Mobotics, for example, but same is true for FLIR and for Axis and Hanwha. I would recommend you take a look at our supported device list and what the individual capabilities of each camera can do. Once we absorb the data, dependent upon what other systems we are unified with, will determine what your outcome will be, right? So if I just wanted to send video to a specific operator, I can do that. If I wanted to, lock a door, I can do that too. So that's what we're talking about. Genetec protocol is built into Mobotics cameras. That is true. So we have a very tight integration. This is a great conversation. I agree, James. This is a great conversation. I am glad that we're having it. You're welcome. I'm going to end it there. I think that's good, unless there's any other questions.
There's actually a good question from
go ahead, Steve.
Don, and he asked, Vince, the model number for the suggested camera would be M16 Thermal TR. So if you were to recommend a camera today, you said yes already, but that's the one you'd recommend.
Well, I have two. Yeah, I have two thermal cameras. That's the one that we're
Unknown
using.
participant is now exiting.
So that's the one we're using the most of. It's got the two sensors side by side, so you'd have a thermal and a color. They're already aligned. It's got a built-in speaker, a built-in LED. So you've got audible alerts. We can control the LEDs. So maybe flash a solid green, and then when there's a detection, play a sound for the speaker and flash a red. Right? We can do all that. It's all self-contained. So that's the one that we're using. There's two fields of view. There's 45 degree and 25 degree. There's also a telephoto, but that's not to be used for this application. That's more for like fire stacks and commercial applications. So yeah, basically two versions of that camera.
Do you have any in a casino environment?
Not yet. We certainly will. They're all shut down.
Yeah, exactly. They're going to be looking for something.
Yeah,
and it'd be the same camera.
Yeah,
right?
basically.
The
casino. So that might be that they might opt to go with the second one, which is more discreet. The S16, the one Steve has, that does the same performance, but it requires a little more work to install. It doesn't have the speaker built in, so there's some inconveniences there. They might do it though, because casinos are always very protective. They always want things to be discreet, so they might do that, and they're not going to use the speaker either. Whereas it all depends on their deployment. If they have a checkpoint, then they would use the M16. But
sure,
I would keep it simple and just recommend the M16. It's just an easier deployment. Everything's aligned already, and you're good to go.
Yep. Tim Kelly asks the question that I know a bunch of people are thinking, and I wish you wouldn't have asked this question, but we'll answer it anyway. Can you incorporate facial recognition? So, yes. I mean, obviously, Mobotics, you don't have. Do you? I don't know. Do you have a facial recognition solution?
Yeah. So no, we don't, and yeah, no, we don't do it ourselves. We are basically the eyes for that. I will say that yes, in theory, you would do that. You would basically have the thermal sensor. You'd have the other optical sensor, and that's the one that the facial recognition would be tied to a server. That would be analyzing that, and then you basically would be using the outputs on the Genetec system, and tying that information into there.
Yep.
Yeah, but in theory, yes.
The thing that would concern me, and Steve, I'm sure you're cringing, is that you've got the camera, you've got the facial recognition framework, whatever that is, right? With pick your brand. And then you've got Genetec or whoever your video management system is. You've got to have all of those things working in concert. And I would be afraid of, facial recognition has a certain accuracy level. This technology has a certain accuracy level. and then what we're going to do with it, or what the video management system is going to do with it once it gets there. You just, with facial recognition, just with any other video analytic, you inject a certain level of accuracy there that may or may not be fitting for the application. Is it possible? Yeah, it's 100% possible. And if you want to have a detailed conversation about that, we could certainly take that offline. Kiwi Vision, no, Kiwi Vision does not do any facial recognition, although Kiwi Vision does have a number of other video analytics that could certainly be incorporated with. So like fence line detection, if somebody comes over your fence and is above a certain temperature, yeah, we could potentially have an alarm trigger based on that. Facial recognition technology app, any possibility to incorporate with Clear ID? Isaac, I had that same question, like build in some sort of thermal sensor into the kiosk, right? So that I can, at least prevent guests from credentialing in or being allowed into the facility. I don't think so at this point. It's too early to tell. Certainly, I will bring that question back to the Clear ID folks. Is the person's temperature considered confidential with regard to HIPAA? Should the video from the M16 not be recorded? Ooh, great question. This is a policy question. Lynn, your question of the day right there. That's a good one. Vin, any thoughts on that?
Well, it wouldn't identify the person, so it would just be the imagery. Or cameras in a hospital now.
What I would
device, so it's not really recorded. It can't be used in a courtroom anyway, right? So it's more just a screening.
Okay. Well, I would say like for your camera with the dual sensors, right? So if you had a thermal, if your video manager is recording the color overview camera, yeah, I could see there being a HIPAA challenge there. Now, I will say that Genetec does have a privacy protection video analytic that will redact people from a scene. So for things like HIPAA compliance and whatnot, again, I would say, run that by the legal counsel of the particular end user to see if that's a valid use case for it. But that would certainly be a policy and procedure question.
What about this? What about not having the second sensor and just using the thermal?
Well, yeah, that's certainly,
and operate off alerts. If you have it attended, you just watch the screen and know that person is the one that created the alert. I'm going to get that person escorted aside, but there's no record of it. Even if they have the video, you can't identify the person.
And what I like about that too, that's using a camera as a sensor, which is not typically how we think about using cameras. It's almost like shooter detection systems, for example. It's an acoustic sensor. It's a microphone, but we're not listening to the audio from it. We're listening for specific events. I think that's actually a really good use case for it. Can you create dual authentication with vertical transportation programs? Example, no temperature with Mobotics and card swipe can enter elevator. Theoretically, yes. Steve, what do you think about that?
Yeah, maybe you could tie all that together. It wouldn't necessarily be easy, but it's. I mean, look, technically anything's possible. It's software at the end of the day.
Yep. We'd have to, Ed, let's maybe take that conversation offline if you want to.
It's a deeper conversation for sure.
Yeah, that's definitely a deeper conversation.
So we got to pick it apart.
Yep. So with that, in conclusion, just kind of wrapping this thing up, this is like indeed a very strange new world. I hope this conversation has served to temper some of the expectations that are surrounding thermal imaging cameras and given you some food for thought at the very least. If you have any questions, please use us as a resource. We want to be your trusted advisor. Again, we're not trying to sell you anything. We just want to dispel some of those rumors. You have my phone number, text, email, social media. I'm happy to answer any questions. Vin can be reached. All of his contact information is readily available as well. Thank you very much for your time. Isaac
is now exiting.
Thank you very much to everybody that is saying thank you. And Vin, I can't thank you enough. And please pass my gratitude on to the folks at Mobotics for keeping the communication consistent. Steve, thank you again for
now exiting.
keeping me honest as well. Thanks everybody. And if you would like a copy of this, just let me know and I'll send you a link to it on my OneDrive. Thanks everybody.
Thanks
Stay
everybody.
safe out there.
It made my day seeing all the gratitude here, which is nice. That's what we try to do. So.
Yeah, stay well, everybody.
Multiple people are now exiting.